Matter of fact, for the remaining of this chapter, we're going to focus on vectors in R3 in 3 dimension. But remember, when we had the point A, B, well, we didn't talk about it, but you can draw conclusion from the 3D, from the R3 example. All right, so let's say that given 2 points in space, given points in R3, let's say A that has coordinate x1, y1, z1, and B that has coordinate x2, y2, z2, okay, then the vector, let's say V equals the vector AB from A to B, is given by and we can write V is, if we use this notation, it will be the difference in the x values in the x coordinates. So it will be the quantity x2 minus x1, and then the y component, of course, will be y2 minus y1, and the z component will be z2 minus z1. Okay? We can write it in this notation, or if we write it in IJK notation, we can write it as x2 minus x1 in parentheses times I plus y2 minus y1 times j plus z2 minus z1 times k. The convenience of this second notation is that you write it as almost, not almost, you write it as an algebraic sum, because you add vectors in 3 different directions, all right? And that gives you the vector itself. I think we are good for an example. All right, somebody remind me to undo the split. No, maybe somebody's still writing. I see at least one person who is still writing. So here's the first example. Find a vector connecting thank you. Connecting the points, and one point will be, let's say, 2, negative 3, and 4, and the other is negative 2, 5, and 7. Okay. And determine its magnitude. Thank you. So we didn't talk about the magnitude of a vector, but so that would be an opportunity to introduce the magnitude of a vector. Okay. So the solution, we're going to let a vector, in this case a V, be, if we use the IJK notation, then vector V would be, if you let the first point to be, let's say, x1, y1, z1, and the second point be x2, y2, z2, then we're going to subtract. So we have negative 2 minus 2 times I, and then plus, we have 5 minus negative 3 times j, plus 7 minus 4 k, and bring it home. So we have negative 4i plus 8j plus 3k. That's our vector. Okay. I'm going to soon drop the error above the ijk because we are not going to use ijk in any other context. So our ijk is going to be our standard unit vectors. Okay. Or we can write it as with the triangle notation. We can write a v equals negative 4, comma 8, comma 3. What is the magnitude? Okay, magnitude of vector. Okay. The general magnitude given a vector v equal, let's say, ai plus bj plus ck, then the magnitude of v denoted by, and I'll use this notation. As I said, the book does not, the book drop, well, the book used bold instead of arrow anyway, is given by, so we're going to write v like so. It will be the square root of a squared plus b squared plus c squared, like so. Okay. So this is the general form. Now, how we obtain this result? If you look at the definition of the distance formula from last class, you can see that this is exactly what we have. The magnitude is the distance between the initial point and the final point, and A, B, C give you the different component, the different distance component. So A will be the difference between x2 and x1, B the difference between y2 and y1, and so on. So it's nothing but the distance formula. So in our case, going back to the problem, so in this case, we have the magnitude of vector v will be the square root of, so it will be negative 4 squared plus 8 squared plus 3 squared, like so. So we are looking at 16 and 64, right? So that's 80 and 3, 89. I think 89 is a prime number, so there is no way to simplify it. So this is the magnitude of the vector.